Alright, welcome to Unit 2, Lesson 2, Newton's First Law. Now today's lesson is really just a small extension on yesterday, or last day's lesson, or the previous video, which was net external force on an object. So with Newton's first law, there's a couple points that are made in your notebook. The three of them, or two of them are that an object at a constant velocity is going to try to resist accelerating, which means that if it's moving at a constant velocity, we're going to say that its acceleration is 0, and if its acceleration is 0, it means that its net force is 0. So there's a couple scenarios we're going to add onto this. First off, if an object is moving at a constant velocity, there's a new piece of hidden information that the questions are giving us. It's telling us that net force on that object is 0. Likewise, if an object is just sitting there and not moving, the net force on that object is still 0. There's no real difference in the value of net force if an object is sitting still or moving at a constant velocity. In fact, technically sitting still is still just moving at a constant velocity of 0. Okay, so let's jump into this first example problem here, and we will demo this idea mathematically with the diagram. So this question says there's a 250 kilo car traveling forward at a constant speed of 60 kilometers per hour, and that car experiences three horizontal forces: a forward force of 11 kilonewtons, a friction force of 3 kilonewtons, and an air resistance that we do not know, that we need to determine. So let's get a sketch going here. I'm just going to draw my car as a red box. It weighs 250 kilos. I'll let you know that for this question today, the mass is irrelevant. Tomorrow, the next lesson, lesson 3, it won't be quite as irrelevant anymore, but that's for the near future for us to worry about. Okay, so we're moving at a constant speed. That constant speed is actually our first tip-off on this question. If we're moving at a constant rate, a constant speed, our net force on the object is 0. It means that the strength of the forces acting in the forward direction equal that of the reverse direction. So let's say already we know that our F net is equal to 0. That's a good start. Make that look a little nicer. Okay, it's now experiencing three horizontal forces. So three forces all moving within the x direction. Let's see if we can determine what those are. The first force is a forward force. I'm going to make right my forward direction. So maybe I will also sketch that on here. And we can say that this is our positive direction, this is our negative direction. Okay, first forward force. Moving that way, and it has a magnitude, force 1, of 11.0 kilonewtons. Alright. The second force is a friction force. So friction, or resistive force, that's going to be moving in the opposite direction of our travel. So it's going to be moving backwards. So let's put this F2 here pointing backwards. F2 is equal to 3.0 kilonewtons. Alright, now we have a third force. Third force is air resistance. So I mean we can assume that that force is moving backwards. But let's prove that mathematically. So let's put down here our F3 is unknown. Okay, well, we have a formula from yesterday. That formula states that F net is equal to the sum of all of our forces. So here we have our F net plus 3 forces. So I'm going to say F net is equal to F1 plus F2 plus F3. Good. Okay, let's add in numerical values to this. All we're missing is F3. We can fill in F net, F1, and F2. Let's see what this is. So F net is 0 is equal to 11.0 kilonewtons. it's right and forward, so it's positive. We're going to be adding a negative value or subtracting our friction resistance force, so 3.0 kilonewtons plus our F3. Alright, we're just going to solve for F3 now. So if we punch that into our calculator, our F3 is equal to, well, I get negative 8.0 kilonewtons. That's negative 8.0 kilonewtons forward, or we can rewrite that as 8.0 kilonewtons backwards. There we go, F3. We can call that F air if we wanted to, but I don't think that's totally necessary. There you go, put a box around our final answer, and we're done.